Multiplying and dividing rational expressions. First, let's talk about simplifying rational expressions. A rational expression is simplified when the numerator and denominator have no common divisors. So, in order to make sure that happens, first we need to completely factor the numerator and denominator. Then, cancel out any factors that are common to both the numerator and denominator. And remember, you can only divide out common factors, not individual terms. So let's go ahead and work out this first example, simplifying the following rational expression. So in the numerator we have a 4x. There's nothing we can factor out of that, so we'll just leave that as is. In the denominator, we have a GCF of 4x that we can factor out. So when we take out a 4x cubed divided by 4x, that's going to leave us with an x squared. And then 12x divided by 4x, that leaves us with 3. So the top is the same, we factored out the bottom. Now you should notice that we have a 4x on top and a 4x on the bottom. And so since they're common factors, we can cancel those out, and then we're left with 1 over x squared plus 3 as our simplified answer. Let's work out a couple more examples. In this next one, again, in the numerator there's nothing that we can simplify, so we'll just leave that. In the denominator we have a trinomial, so we want to factor that into two binomials. So our first terms are x and x. We want the factors of positive 6, which is 6 and 1, 2 and 3. And remember, they need to add up to positive 5. So we're going to take positive 2 and positive 3. So once we've factored the denominator, you can see that we have this factor x plus 3 on top and a factor x plus 3 on the bottom. Those are going to cancel out. So we're left with 1 over x plus 2. Now we don't have to have those parentheses in that final answer, but it's not incorrect if it's written there. Let's go ahead and work out example 3. If you feel comfortable, I want you to pause and try this on your own and check back with me. Otherwise, let's work through it step by step. On the top, we want to first see if there's a GCF to factor out. All of these terms have a factor of 3, so let's pull that out first. So we're left with x squared minus x minus 2 when we factor out a 3 from each of those terms. And then along the bottom, we don't have a GCF, so let's go ahead and just leave that as x squared minus 4 for now. Our next step is to factor this trinomial and this binomial. In the top we have 3. That 3 stays on the outside, and again we want to factor this. So we have x in the front. We have a negative 2, which tells us that our signs are going to be different. So the only factors of 2 are 2 and 1. So how do we get a negative 1 when we add these two together? We need a negative 2 and a positive 1. Then on the bottom, remember, when you only have two terms, if they're both perfect squares with the subtraction, we can use difference of squares to factor this. X minus 2 and x plus 2. Now that the numerator and denominator are fully factored, let's go ahead and cancel out any common terms. We have an x minus 2 on the top and the bottom, so those cancel out. So then we're left with 3 times x plus 1 in the numerator over x plus 2 in the denominator. And there's our simplified answer. Next, let's talk about multiplying rational expressions. When we're multiplying, there are two different methods that we can take on. In the first method, the first step is to multiply the numerators, and then multiply the denominators, and then simplify what we can, following what we were just working on. So let's go ahead and apply method 1 to this problem here. So we're going to multiply the numerators. So 12 times 2 is going to give us 24. X squared times x to the first is x cubed. y to the first times y to the first is y squared. Then the denominators, 5 times 3 is 15. We just have an x squared, and we just have a y squared here. So once we've multiplied the numerators and then multiplied the denominators, now we want to take a step and simplify. So let's go ahead and simplify these numbers. 24 over 15. This is going to simplify 8 over 5 because 3 is the biggest number that goes into both. X cubed over x squared. So remember, we subtract exponents when we're dividing like bases. And so 3 minus 2 is going to give us 1x on the top. Y squared over y squared. That's going to cancel out. So we're actually just left with 8x over 5 as our final simplified answer. Now for method 2 in multiplying rational expressions, the first step we want to do is factor the numerator and denominator. Then we want to cancel out any common factors. Then we'll multiply the numerators and multiply the denominators. So let's go ahead and try method 2 with this problem. So we want to factor the numerator of each and the denominator of each. So here, x squared minus 2x, we can factor out a GCF of x. So we're left with x minus 2 along that numerator. And then in this other one, since we have a trinomial, we want to factor that into two binomials. The first term is going to be x in each one. The plus tells us the signs are going to be both positive. And then the only factors of 3 are 3 and 1, and they do add up to 4. So these are our factors. And let's factor the denominator. So again, we have a trinomial, which should factor into two binomials, x and x. The factors of 1 are 1 and 1. And we want them to be both positive so that they add up to positive 2. And then this denominator, x squared plus 3x, we can factor out a GCF of x. So we're left with x plus 3. So now that we've factored out the numerator and denominator, next we want to cancel out any common factors. So again, I know we have two sets of fractions, but anything that's on the numerator of either fraction can cancel out with the factor that's in the denominator of either fraction. So this x can cancel out with this one, since we have one on top and one on bottom. The x plus 3 and x plus 3, and also the one of the x plus 1's down here with the x plus 1 up here. Then, when you multiply the numerators and denominators, or whatever's left, along the top we have x minus 2, and then on the bottom we have x plus 1. And this is going to be our simplified answer. Now it doesn't matter whether you use method 1 or method 2 when you're multiplying rational expressions. However, depending on the problem, it is going to be easier to use method 2 sometimes over method 1. So when we're looking at this third example, when you see trinomials in here and binomials, it's going to be easier to use method 2 to multiply these together. Otherwise, you're going to be multiplying trinomials and then trying to factor, and it's going to get kind of messy when you get to the simplifying step. So let's walk through this example together. First, we want to factor the top. So we can take out a GCF of 2. So we have x squared minus 1. And then along the bottom, we have x and x. The only factors of 7 are 7 and 1. And if we want them to add up to negative 6, we get negative 7 and positive 1. Now when you look at the second expression, technically it doesn't look like a fraction. But remember that you can turn anything into a fraction by putting it over 1. So we're going to go ahead and factor that trinomial as well. We get x and x. And then the factors of 21, we have 7 and 3, and then 21 and 1. So we want them to add up to a negative 10, which means we're going to have to use a negative 7 and a negative 3. Now, Before we start canceling, you want to make sure that we have factored everything possible. 2, x minus 7, x plus 1, x minus 7, x minus 3, those are fully factored. But here we have this binomial again. X squared and 1 are perfect squares, and they are separated with a subtraction sign. So we can actually factor that further into x minus 1 times x plus 1. So we're going to factor that term, or that expression, sorry, even further. And then everything else that we previously factored, we're just going to rewrite it. And then now we can go ahead and cancel. And again, remember, it doesn't matter which expression it's in, as long as you cancel out one thing from the top that matches something on the bottom. So here we have x minus 7 and x minus 7, x plus 1 and x plus 1, and there's nothing else we can cancel out. So let's go ahead and multiply what we have left. Along the top, we have 2 times x minus 1 times an x minus 3, and on the bottom, the denominator, it's just 1, so we can actually just leave our answer like this. And you want to leave your answers in factored form. You don't want to multiply these back again. Now let's talk about dividing. When we're dividing rational expressions, we want to multiply the first expression by the reciprocal of the second expression. So what you need to remember is to keep the first fraction exactly as it is, change the division sign to multiplication, and then flip the second fraction. So let's go ahead and practice that. So in our keep, change, flip, we want to keep this first expression. We want to change the division sign to multiplication, and then we want to flip the second fraction. Now we could use either method 1 or method 2 from our multiplying rational expressions to simplify this. I'm going to go ahead and use method 1 just so we get in a little more practice with that. Method 1 is where you multiply the numerators and multiply the denominators, and then we'll simplify. So 5 times 12 gives us 60 times x to the 5th. And then in the denominator, we have 8 times 15, which is 120 times x squared. Now we can go ahead and simplify. 60 over 120, that's really 1 over 2. X to the 5th over x squared. So remember, the bases are the same, and since we're dividing, we're going to subtract those exponents and put it where the bigger exponent is. So 5 minus 2 is 3, so we have x cubed. And just for notation wise, we don't want to put that 1 as a coefficient in front of x. So your final answer will be x cubed over 2. Let's go ahead and walk through a couple more examples. So we want to start off with our rule of keep, change, flip. So we keep the first fraction, x squared over x squared minus 1, change the division to multiplication, and flip the second fraction. So x plus 1 comes to the top, and 3x goes to the bottom. And then, when we multiply these, remember you have two different options, but in this case, as soon as you see binomials, it's going to be easier to use method 2. So method 2 involves factoring the top and bottom of both fractions before we multiply. So x squared, it's only one term, there isn't really anything we can factor out, but I'm just going to rewrite that as x times x. And then the bottom, we have x squared and 1. They're both perfect squares with the subtraction in between. So we get to use difference of squares, take the square root of each term, and then we have x minus 1 and x plus 1. Then, in our second fraction, there's nothing we can do to the top, and there's nothing we can do to the bottom, so they just stay as is. Now when we go to cancel out common factors, remember, one factor from the top and one factor from the bottom. So we have x plus 1 on the top and bottom. And this is the reason why I separated x squared into x times x. Because you have one x here on the bottom that'll cancel out with one of these. So now that we've canceled out all the common factors, let's go ahead and multiply straight across what we have left over. On the top, all we have is x. Along the bottom, we have a 3 times x minus 1. And here is going to be our simplified answer. So if you feel comfortable with this, I encourage you to pause, try this example 3 on your own, and check back with me when you're finished. If you're still feeling iffy, just stay with me and we'll go through this step by step. So again, we'll start off with our keep, change, flip. So we'll keep the first fraction. Change the division to multiplication, and then flip the second one. So x squared minus 9 comes to the top, 15x cubed plus 45x squared comes to the bottom. And again, because we have binomials and trinomials, method 2 will work better. So let's go ahead and factor. Along the top here, we have 2 terms, so let's factor out a GCF. 5x is going to be our GCF. So when we divide that out, we're left with x plus 2. And along the bottom, our trinomial will factor into 2 binomials, x and x. And the factors of negative 6, we have 2 and 3 and 6 and 1. If we want them to add up to a negative 1, we're going to need to use negative 3 and positive 2. And then in our second fraction, again on the top we have 2 terms, but they're both perfect squares separated by a subtraction. So we'll use difference of squares, take the square root of each. So we have x minus 3 and x plus 3. And along the bottom, with our 2 terms, we want to factor out a GCF. So from 15 and 45, 15 is our GCF. From x cubed and x squared is the biggest one we can take out. So when we divide that out, we're left with x plus 3. Now that we've factored the top and bottom of both expressions, let's go ahead and cancel out what terms we can. Here we have an x plus 2 and an x plus 2. We have x plus 3 and x plus 3, x minus 3, x minus 3. And here, remember, this x squared is really x times x. So I'm going to rewrite that so that we can cancel out one of these x's with this x. And then lastly, 5 over 15, 5 goes into itself once, 5 goes into 15 3 times. And so I know it got kind of messy, but let's go ahead and write what we have left. Along the top, we've canceled everything out, which means we're just left with 1. And along the bottom, we have this 3 and 1x left over. So 1 over 3x is going to be our final simplified answer. That's it for this lesson. I'll see you in class for more practice.